put in presentation mode.
Okay.
So my talk will be regarding the ethical and social issues when we try to enter or to integrate a collaborative robot in a manufacturing or production line. I belong to Technology Research Center in Spain, and together with other members of the consortium, we work in a SMARTHANDLE project, which will finish this year in December with the pilots and validation task regarding how we are going to integrate robots and humans in the production line. The problem that we have identified within the SMARTHANDLE is the manufacturing industry in Europe, which is representing 33 million jobs in the region, with high level of growth, or 60% of productivity growth in the coming year. And the problem that is that the people and market are demanding more and more different products with shorter life cycles. So this implies a problem of how to reconfigure the production lines and how to change rapidly the machines, the robot, the automated means of production in order to offer those quickly changing products to the market. The aim is obviously to produce more and more differently with less means, less production means, and short changing times in the production lines. The objectives of the SMARTHANDLE project, you can see here, is obviously to focus on the more automation and intelligent development of new production lines, in integrating also collaborative robots, software based on artificial intelligence, and higher degree of parameterization of all the production means. But also we are trying to put the focus on how the workers will accept the presence of collaborative robots together with the workers in the manufacturing lines. And that's why we have a complete work package dedicated not only to the definition of requirements, but also to the definition and creation of design guidelines in order to have the human worker in the center of the
Sorry,
design of the whole manufacturing. Sorry?
Yeah.
I think your presentation is not shared.
Yeah. I was.
Okay. I will stop
Yeah. The
sharing.
slides are not. Yeah. The slide we're not changing. Yes.
Oh, okay. Sorry.
No, don't worry.
I will stop sharing and share again, maybe.
Yes. Yes. You already stopped sharing.
Yeah. I'm going to share.
Maybe it is the second screen, I think.
Okay.
Can you see now? Maybe it's not the presentation.
It's
No.
not full mode, but I guess it is the second screen.
Yeah, I want change to full mode and keep like this. Maybe it's better. So you can see now the slide with the objectives of the
Yes.
project.
Mhm.
Okay. I was mentioning that apart from all the research and development within the project on the technological part, artificial intelligence, reconfiguration means, high-level software, we are going also to focus on the definition of guidelines in order to have the worker in the center of the manufacturing lines. So the idea is to develop intelligent and reconfigurable agents within the project, both software and hardware agents, smart handling tools, and high-level sensorization and monitorization of the lines. But as you can see, we will have also people working together with robots in all the cases that we are going to validate, both on the steel manufacturing, the pilots regarding consumer goods handling, and also the disassembly of car batteries. We will have people working together with collaborative robots, and this implies a lot of problems of acceptance, of safety, and everything. Why? Because we have the problem that a person and a robot must collaborate in a way that the people or the worker has enough rely on how the robot behaves when the robot is moving around the people. There is a complex communication and feedback loops between the worker and the robot that must be clear enough for the worker to trust that and to be safe enough with when he's working and moving around a collaborative robot. And what we can see is that now with the integration also of artificial intelligence within the robotic, we have more and more risk for the operator that maybe he doesn't or she doesn't know how the robot will respond to a specific posture of the body or posture of or the hands of the worker, are trying to see what will be the next step that the robot will take, depending on the position of the worker or the gesture that he does with his hands, his arms, or whatever kind of communication between the two, the robot and the worker. Here we can see some statistics that we obtained in a past European project that we did regarding the analysis of collaboration between workers and collaborative robots or interfaces between people and robots. And we were performing some surveys, and we obtained some information from a lot of people from different fields of industry. You can see here how they feel of the presence of robots in the manufacturing lines or in general in jobs in Europe. They think that the robots won't steal the jobs, but that the robots will be necessary, but they also will need some kind of careful management. So they don't trust 100% on the robotics part. If you see this statistic, this shows that people are accepting robots as far as they are in a well-limited working place. If the robot is in a manufacturing site, okay, they will accept, because usually the robot used to be in a very limited space with fences and a lot of safety measures in order to avoid any accident between robot and human. But if you see how they accept the presence of robots in another kind of environments like education, caring of elderly, or medical areas, the level of comfortability is decreasing. So we have to pay attention to this kind of issues when we are talking about how to integrate robots and people. About 75% of people think that the privacy data and the personal data could be in a risky way in the future regarding the use of robots and artificial intelligence in the everyday life, and also in the working life or working environment, where more and more a lot of data are being used. Some statistics also shows that the people usually disagree when they are asked about the importance of who could be the first thing to take into account. On one side, the economics and productivity of the manufacturing line with a robot, or the ethical and social issues when trying to integrate that robot. They think that the ethical and social issues should be also taken into account when trying to put a robot in the working place. Also, that from their point of view, they agree that up to now too little attention is being paid to the needs of the workers when a manufacturing workplace is designed. The company usually defines all the manufacturing lines, all the tasks, all the machinery, thinking about the productivity, the cycle time, how many robots, how many machines which is the best layout for the robots, for the machinery to produce more products in less times, and few times the comfortability or the well-being of the worker is taken into account. So the thing is that we should think about how the person behaves when he's or she is working together with a collaborative robot. When there is a place where the arms, the hand, the body of the person is the same area where the robot also moves in a certain speed. It's true that the collaborative robot usually moves a bit slower, and when the robot is approaching to the human, uh, the robot slows down, but on the other hand, the company wants a robot to perform rapidly the task in order to be proficient enough. So we have here a balance between how the robot is behaving and trying to produce the products and doing the tasks, and how the human worker has to behave in order to feel safe, to feel comfortable, but also to feel that he has the control or the decision about the task over the robot. So this is a balance not only on the physical part of the collaboration between human and robot, but also on the psychological part of the collaboration between human and machine. Here we have a lot of interaction, how the robot with a lot of sensors may interpret the movement of the worker, and just the opposite, how the worker interprets the movement of a robot, how the robot approaches to a certain point when where the user is also doing some kind of task. So we must design a common protocol which is convenient both for the human and for the robot in order to make the things be produced, but also in order to make the worker feel safe and confident enough. So we can think about how we can translate the ethical principles that were applied in the past to the human and the normal life of humans, to the now increasing use of collaborative robots in manufacturing lines or in everyday life, not only manufacturing, but robots in other fields of production. And we can define those 7 principles that are recognized by experts in ethical and moral principles. Just a quick review that talking about human dignity, that is respecting human dignity and integrity, the creation of robot designs aim at protecting the workers' vulnerability and the growth of the workers' capacities. The second one, protecting vulnerable individuals that they are able to contribute to the development of the autonomy. The third one is, of course, the value of privacy and confidentiality of personal data. The fourth is the robotic designs must be subjected to testing to guarantee the security and physical safety of the worker, but also the integrity of the worker. The fifth is the principle that means that potential harm must be minimized and the benefit must be maximized, improving the quality of life. The sixth is sharing the benefits when we take into account some populations that could be in a disadvantageous position. For example, elderly workers, women that are now entering in the production and manual handling and manual operation. Maybe they need to be treated in a different way when we try to enter a robot to collaborate with that specific kind of population. And the last one is respecting and protecting the environment and future generation in order to avoid the robotic divide or robotic gap, that every people should be able enough to work within a robot independently of the background of the people. We have worked also on the so-called responsible research and innovation, trying to develop engaging technologies and not alienating technologies. No? So we should think about how to define and construct and to integrate a robot into a production line, following those 5, let's say, parameters or objectives. No? Trying to get a robot that is open to every kind of manufacturing requirements, versatility, docility, that is that the people doesn't feel threatened by the robot, and also thinking about how the robot will be repaired, updated, and maintained, and all together with the needs of the company. And of course that the worker is able to understand the behavior of the robot with easy to understand instruction and a comprehensive design of the operation that the robot is taking. In the case of smart handle and focus on the analysis of how to integrate the human worker within the manufacturing lines that we are developing within the project, we have designed the so-called design guidelines, human-centered design guidelines. We have developed about 25 or more guidelines that are more or less classified as these 3 groups, take into account the human characteristic, the task characteristic, and the robot characteristic. And the thing is that the manufacturing line should be defined taking into account the task in such a way that the humans' cognitive and physical abilities are well utilized and well used, and the human worker should perceive the contributions and be sure that he has the control over the work of the robot. So he feels or she feels that he's valuable and impactful. And also a well balance between the responsibilities of the human and the work and the robot should be stated. So the human feels that he supports the robot, but when he needs someone from the robot is able to react in time and to be in a well balance between the tasks that are performed by the robot and the worker. The thing is that the robot should provide also enough feedback to the human to be sure that the collaboration is in time and with exact information that are required. That's why the robots should have enough sensors and means of sending the useful information to the worker, and just in the opposite side. And also that the human worker should have enough autonomy to take the exact decision when the robot needs, and also to control the execution of the whole task in the manufacturing and the decision making. So the balance between the robot and the worker should be the right one in order to have the worker happy and with the feeling that he's safe and that he has the control over the robot. Just to finish, there are some groups working on ethical and social issues at European level, and some standards that you can see on the slide. And we see that more and more different bodies and agencies are working on that part of the technology development when dealing with interactive robots. Because not only in the manufacturing area, but also in other areas, when robots try to be used, there are more and more problems regarding the acceptance and the social acceptance of interactive robotics by the people, not workers, but maybe normal people in their everyday life. So this is all from my side. Thank you for your attention, and I keep at your disposal for any answers at the end of the webinar.
Thank you.